lines until infinity. There's no ending. So we can say the range for this straight line are all values of y, where y must be a member of R. Okay? Next, for y or fx equals to x squared plus 1, so this is how the curve will look like, and the minimum point 1 will be here. Y equals to 1. So when we find the domain we plot one point, any point from the curve onto x-axis. We can see here the value of x will move towards infinity, no ending. We can continue plotting lines on the x-axis until infinity. The same goes for the positive side. It's also until it will move towards infinity. So we can say domain are all values of x, where x is a member of real number. Okay? Next, for range, we have to take a point from the curve and plot dotted lines against the y-axis. So we have no problem on the top part because this will continue until infinity. But at the bottom, the value of y must be minimum 1. Anything below this curve, there's no more value for y. So in other words, the range will be all the values of y, where y must be a member of real numbers R, but the condition is the value of y, the range here must be above y equals to 1. Therefore we write as y greater or equals to 1. So this is the condition for this range to exist. Okay, next, what about y equals to 1 over x minus 4? So for this type of chapter, this type of questions related to domain and range, we have to be careful of two things. The first thing is the fraction, the second is the square root. So for a fraction like this, 1 over x minus 4, in order to find the domain will be all the value of x. Okay? But in this fraction will only exist if x minus 4 is not equal to 0. Remember, the denominator can never be 0 for y to exist. So therefore we can say x minus 4 must not be equal to 0. When we move the negative 4 to the right hand side, we can say x must not equal to 4. So domain now will be all values of x, where x is a member of R and x must not be exactly 4. Okay? If we substitute 4 here, 4 minus 4 will be equal to 0. Okay? So that will make the value of y not real, so we can accept that value. Okay? And let's look at the range. In order to find the range, the first thing is we have to move the x to the left hand side and y to the right hand side. So we interchange this fraction. Then from here we will get x equals to negative 4, shift to the right. We will have x equals to 1 over y plus 4. Again, this domain will only exist when y is not equal to 0. Because here we have 1 over y. And y must not be 0. If y is 0, then the value of x will not be real. So therefore we can say range will be any value of y as long as the y must be real number and y must not be equal to 0. So we write the symbol not equals as this. Okay? Next, if we are given a question involving square root, alright? For example, y equals to square root of x. Remember I said in a square root the value of x must not be negative. If negative, we cannot find the answer. So in order to write this in mathematical terms, for x equals to not negative number, then x must be greater or equal to 0. So we can straight away say domain will be any value of x as long as it is a member of real number, and the limit is x must be greater or equal to 0. Okay? Next, in order to find the range, we have to first move the square root to the left. So we will have y squared equals to x, or we can write as x equals to y squared. Remember, you want to find range, the x must be on the left side, the y must be on the right side. Okay? So from here, since this is a square, y, if y is equal to any real number, when you square it, then the value of y has got no ending. Because here we can substitute any value of y until infinity, therefore there's no restriction, no limit. We can say y is moving towards infinity. That means, in other words, we can say any value of y as long as it is a real number. So we can write the answer as range equals to all values of y, where y must be a member of R.